Algebra 1, Study Guide number 8, page 1. Number 1, simplify. Write in standard form. Standard form is when you take actually this one is in standard form because you've got the highest degree of the exponent. You're just looking at the variables. 2 degree, 1 power of 2, power of 1, and no x's. So x squared, x to the 1, and then no x's. So this is what we want to do. So I'm just going to match them up. I've got my 4x squared, and it is addition, and I've got my minus 4x squared. So 5x squared minus 4x squared is 1x squared. You can put the 1 if you want to, or you can just leave it understood. And then I have my x's, so I have a negative 12x plus a positive 15x, which is a positive 3x. And some people lightly mark these out as they're through with them. And then you have your constants, which is a positive 6 plus a negative 11, which is a negative 5. And if you'll do them in order, you've got your standard form. Now this one is subtracting. You've got to do a little extra work before you be able to put them together. And you want to take, there's several ways to do it. I think the easiest is to take that negative 1, that understood negative 1 right there, and distribute it. So I'm going to bring my 4m squared minus 8. I'm just going to bring those over like they are. And then I'm going to have minus negative 1 times positive 12, which is negative 12. And then my negative 1 times my positive m squared is a negative 1m squared. And then negative 1 times negative 6 is positive 6. Now let's put our like terms together. Standard forms. Let's do our squareds first. Well, I just have 1. There it is. Oh, there it is. 4m squared minus 1m squared. Almost missed that one. So I've got 3m squareds. You can mark them out if you want to. And then I have a plus 3m, and that is the only m I have. And then in this one I have a negative 8 and a negative 12, which add to negative 20. And then negative 20 plus 6 is a negative 14. So we have second degree, degree 1, and then degree 0 for our variable there. Solve the system by graphing. I need to find some graph paper. I didn't have any graph paper, so I just printed me a sheet. Number 3, and I'm going to, I tell you what, let me write them right here so we can kind of see what we're doing. I've got y equals x minus 2, and I've got y equals negative 1/3 x plus 2. So just a quick review, y equals mx plus b. This is a system. We're looking for where they cross, so we're going to try to be as accurate as we can with our graphing. The slope in this one is remember the m is the slope, so it's what's in front of the x, which is a 1, and that's a positive 1, and we're going to make it a fraction by putting a positive 1 under it. And then my y-intercept is this number here, which is the negative 2. This one, its slope is negative 1/3. Well, remember when you have a negative fraction, one of those numbers has to be negative. So I'm going to put it with the top. You can also put it with the bottom and make one of them positive, one negative, because that's still a negative 1/3 when you divide it. And then the y-intercept is positive 2. That's the number here. Okay, let's get an x and y axis going. And I don't know if you can see that color on that graph paper or not. Let me put some paper under it. Yeah, I think you can. And I've got my x-axis, got my y-axis, and I'm not sure I have a different color pen. If I do, I'll try to graph them in different colors. I'm going to graph this one as the first one. My y-intercept is negative 2, so I'm going to go to the y-axis and find negative 2. And then my slope is 1/1. Remember, that's rise over run. So I'm going to rise 1 and run 1. And I may do that a few times, and just when I connect those, I'm going to turn my paper sideways. I'm just going to be just as accurate as I can be to connect them so that I can find that point of intersection. Okay, so there's the first line. You can see that real well. Now I've got a blue pen, and I don't know if it'll make a difference. I think that one's black. And so this one, if it'll even right, well, I think this is black. We've got a y-intercept of positive 2. So we'll find that on my y-axis. And then I have a slope of negative 1/3. So I'm going to rise a negative 1 and run a positive 3. Now if you flip that over, you would have had a +1 rise and a -3 run, which will give you the very same line. So I'm going to rise a -1 and run a +3, which makes it really nice and easy to find that solution because they do cross. And notice that my solution is where they cross, so that point is an ordered pair. The x comes first, and as I always say, the x-axis gives you the x. So x-axis, there it is. Count it, 1, 2, 3. That's +3, and I'm going to put the sign there just for emphasis. And then the y-axis gives you the y, and that's a +1. So 3, 1 is my solution. Okay, now number 4 is the same type of problem, but instead of doing it by graphing, we're going to do it by substitution. 4 and 5, excuse me, are the same type of problems. Now, with the way this one's set up, where I know what y is, and I have another line, these are 2 lines, and we're again looking for where they cross algebraically, I'm going to take all of this, and I'm going to substitute it for my y right there. So I'm taking this 5x plus 7, and I'm going to put the -5x minus 11 in for the y equals 13. Now let's distribute. We get 5x minus 35x minus 77 equals 13. 5x minus 35x, put those together, is -30x minus 77 equals 13. Now we're trying to get x by itself, so let's add 77 to both sides. And we'll get -30x is equal to 90. To get x by itself, let's divide by -30. And we'll get x is equal to -3. Now remember, because we're looking for a point, that's only our first number, x, which is -3. To get the y, I've got to take that -3 and I've got to plug it back into one of the original equations. And I think this first one looks the easiest. So I'm going to put that -3 all the way back up here. So I'll have y is equal to -5 times -3, that's multiplication, minus the 11. You could have used either equation. It didn't matter. You can put it either here or here. And I have y equals, that's +15 minus 11, which is 4. So these 2 lines cross at the point -3, +4. This one, I'm trying to find a good place to do this one. Let's go down and do this one. Actually, let me just get another sheet of paper, and I'll just do it on top of it right here so we can see it. Y equals -8x plus 6, and y equals -4x plus 2. That way we'll have it right beside it. Now, what's nice about this, if y is equal to this, I can take that and actually put it right there for y, which is going to make -8x plus 6 equal the -4x plus 2. Now, to solve this one, I like to get my x's together first, so I'm going to move this x. You can move either the 8x or the 4x, it doesn't matter. And I'll get -4x plus 6 equals 2. Now I'm going to move the 6. Remember, I'm trying to get the x by itself. And divide by -4. And I get x equals +1. Remember, that's my x of my point of intersection. So now to find the y, we can go back, and in this case, they both look pretty easy. So I think I'll take the bottom one. I've got y equals, I'll just rewrite it over here, -4 times the +1 plus 2. You can put it in either one. You will get the same answer because it's where they cross. It's a point that is on both lines. So I have y equals -4 plus 2, which is -2. And there's my point of intersection for number 5. Number 6, are the tables direct variations? Why or why not? Show your work. Well, a direct variation has to be a line, and it has to go through the origin. So we could graph them. That would be an option. Sometimes it's messy if the numbers are very big. So the easiest way is to consider the relationship of x and y in a direct variation. And the relationship says, and I'm going to go ahead and make me a third column, it says that the constant in the equation, which is actually the slope, a direct variation is simply y equals mx plus b, where this is going to be the origin, which will be 0, and m is the constant. And that constant is the y over the x. So let's just put the y over x in each case and see if they're the same thing. We've got 2/3, 2/3, negative 2/3. So this one is no, because there is no constant. Okay. Let's look at B. Same thing. Let's make us a k equals y over x. Okay, negative 4, negative 2 over negative 4, 4 over 8, and 5 over 10. Well, each one of these reduced to positive 1/2, positive 1/2, positive 1/2. So yes, it is a direct variation because constant, you can write the word out or just put k equals 1/2. And the equation would actually be y equals 1/2 x.